Connected Consumer. Hello, Connected Consumers. I am Chris White. I am a research director at Parks Associates, and I'm here to bring a excellent guest in here today in latest of our series of visits with Infineon. But first, let me tell you a little bit about this podcast. We at Parks Associates cover a variety of segments in the connected home, including entertainment, smart home, home energy, automation, and home services. And in this podcast, we bring in experts from all those spaces, as well as our analysts to discuss important issues of the day, important news, and share insights with you guys, both in terms of what we learned in our research and what our guests are seeing from inside the industry. So today I'm really excited to bring in Bill Stewart, the Vice President of Automotive Americas Marketing from Infineon, and he's going to talk to us about what Infineon does in the automotive space. Hey, Bill, thanks for joining us.
Thanks, Chris. Glad to be here.
Okay, so first, give me started. Tell us a little bit about Infineon broadly, and then a little bit about what you guys do in the automotive space.
Yeah, so Infineon's a semiconductor manufacturer. So we are one of the largest automotive semiconductor companies in the world. And what we focus on are products which enable a lot of the game-changing technologies which are coming into vehicles. How do they become more electric? How do they become more autonomous? And ultimately, how do they become a better product that consumers want to drive?
Okay, and so you guys have a strong position in the automotive space, as you mentioned, and go ahead and tell us, how Infineon is doing so successfully in the space. Give a little plug on the three pillars and tell us how Infineon is better than the competitors on this one.
No, absolutely. So if you think about the future of vehicles, there's a lot of trends that are happening right now. They're becoming a lot more electric. We hear about EVs all the time. You also have a lot more of autonomous features, not just fully autonomous cars, but the cars we drive today have adaptive cruise control, automatic emergency braking, lane departure warnings, pedestrian warnings. And it's not just that. Those are the things that are publicly talked about. But with some of those transformations, you see the entire architecture of the vehicle changing. A lot of the systems today, which are mechanical, are becoming electric. Think about your braking and steering systems. Those are also moving to more electronic systems. With that, we need consumers to trust the vehicle, right? That's a very different experience for them. And as a result, you have to have what we like to call dependable electronics, which is what Infineon offers, able to convey that consumer confidence and enable them to want to use these features. The three main things that get you dependable electronics are very high quality. We measure the quality of our devices in parts per billion. If you think about the amount of you produce chips for 365 days, 24 hours a day, 7 days a week, the number of failures that we get back from our customers out of that full year of production would be 2 seconds. So a massive number of chips in the billions that we're shipping, and we only get a few back from our customers because they are so reliable in the field. The next aspect is security. Right? Vehicles are now connected. You're connected to your phone. They have their own modems. In some cases, the vehicles are talking to each other. And, it's very important that, they're exposed to hackers where they were not previously. And It's very important that they're protected from that as well. And we offer security solutions, both software and hardware, that we embed into our hardware in order to secure the network and secure the connection to the outside world. The last item that is really important is called functional safety. And functional safety is really ensuring that every system in the vehicle performs as you intend. So when you hit the brakes, does the vehicle stop? When you hit the gas, does the vehicle go? Does your speedometer work? Yeah. All of those things are very important. And what we do is we put mechanisms into our devices to help our customers verify that everything is working the way it's intended.
Okay, great. So could you talk to us a little bit about that space? How does it work in terms of working with the OEMs that you're working with? Mm-hmm. And also, in terms of this digitalization of mechanical activities, where did kind of the impetus for that come from? So, is this a scenario where you guys have some tech and you go out to these companies and say you should be doing this in a digital way instead of mechanical, or
Mhm.
are they kind of coming to you and saying we want more digital?
Right. I'm going to answer the second question first, and then I'll come back to the
Okay.
first one because
Turns out I should have
they are
scripted that better. Okay, fair
yeah.
enough. All right, let's do it this way.
That's okay. So, no, I mean, what we see is when you convert these mechanical systems to electric, there's benefits to the automakers. You can save weight. You can upgrade them in the field. Ultimately, you can improve the long-term reliability of the system. In case of electric vehicles, for braking systems, you're already electrifying part of the system because you want regenerative braking, right?
Right.
So as you slow down the vehicle, you recapture that energy. So there's a lot of things driving it. Ultimately, these are driving more and more complexity into the systems from an electronics point of view. Those mechanical systems are not simple today. It is not easy to design a car fully mechanically. So,
Right.
but as we transition to electrical, the complexity of the electrical systems is increasing significantly. And what we do, so traditionally, we were a tier two supplier. So we would supply to a Continental or an Aptiv or someone like that, and they would then supply a module to an OEM. And what we've seen is a change in the overall supply chain to where it's not purely OEM tier one, tier two relationship, but it's a very collaborative relationship with all three parties, including partners. Right. So we're also bringing in third party software partners as well as hardware and reference design partners, especially when we talk about autonomous drive systems. A lot of those systems are being designed by tech companies like NVIDIA and Qualcomm and being brought into the vehicle. And what's happened is we have more of a collaboration between all three parties. And from our point of view, we need to engage with everyone. A lot of times, the capability of what the vehicle can achieve, whether it be range, whether it be performance, what feature it can have, is very dependent on the semiconductors. And if we can't implement a certain networking technology or we can't achieve a certain level of performance, the vehicle will not be able to have a certain range of a radar sensor, for example. And so, with that case, we have to engage with the OEMs to understand their longer term requirements and as well share our technology with them. And then at the same time, keep the tier ones and those reference design partners and software partners all engaged so that we can work together to develop a solution when the OEM is ready for it.
Okay, so you mentioned radar in there. So is that based on the kind of augmented reality piece where it's like the lane assist, or is that for autonomous only?
So the radar is used in multiple cases. If you look at the autonomous drive systems, right, whether it's a ADAS system or more autonomous drive, and by that we mean how autonomous the vehicle is, right? In many of vehicles today, automatic emergency braking is a fairly standard feature. And what that is essentially you have either a forward-looking camera or radar that sits above your rearview mirror
Right.
and is looking out in front of you. In general, those systems are also used for lane departure warning as well. If you have a camera, you're looking at the lanes and for vehicles in front of you.
Okay.
What happens is that radar or camera has to reach a certain range, right? It has to reach 100 meters, 200 meters, 300 meters, depending on the use case it's trying to achieve. And this is where
It needs to have
um,
some range for speed purposes, right? So like if
exactly.
I'm
So
going
the fact if
80, I
you're
need, yeah.
going 80 miles an hour here in the U.S., you can get away with a certain range. If you want to go on the autobahn and go, 250 kilometers an hour, you need a longer range. And this is where these use cases are developed. But also, it's based on what you're trying to detect. Are you just trying to detect a tire 200 meters away, or you're trying to detect a vehicle because a vehicle has a much bigger cross section that the radar can see or a camera can see,
Okay.
as opposed to a tire or something. So
Okay. So is this different? So here, maybe this is multiple questions again. So
it's okay.
in terms of my 2017 Outback, that has
Mhm.
the optics that we're talking about versus a 2030 autonomous driving all electric car, how different
Right.
are those components going to be in terms of what you guys are supplying? Is there like a range of SKUs, and I've got the basic one in my 17, and there's a super sophisticated one that's on test track somewhere in the desert right now? What does that look like in terms of how you guys are kind of contributing there?
Well, I don't think the 2030 car is even to the test track yet, quite honestly. So
Okay.
that's in the
I was
still
hoping you were going to
research
break some
phase.
news here, but okay,
Yeah,
no.
no, unfortunately I can't do that. So I think if we look at it, the vehicles today, the systems are complex, right? It's not easy, even in your Outback, to hit that level of performance. And this is why we see so much investment and so much research going into these autonomous systems. What you ultimately are going to see, so the autonomous systems have three different areas. It has to sense its environment, number one, and that's a combination of radar, LiDAR, cameras, ultrasonics, microphones for sirens, a lot of different things you have to do to detect the environment so the vehicle is aware of where it is and what's surrounding it. And what we really see with the sensor suite is, coming back to those use cases, a fully autonomous car needs to have a much higher resolution and much more in-depth picture of what's going on around it than your 2017 Outback, which is probably looking more at what's going on directly in front of it in a fairly narrow field of view.
Okay.
So, what we see is, in terms of the sensor suite, you're going to have more sensors, as well as more complex sensors to get a higher resolution and longer range. And you probably have some combination, because certain sensors work better in rain than others do. Certain sensors, if it's foggy, work better. And so, as you're trying to cover these different environmental use cases, you have to have different modalities of sensors at the same time. The next part of it becomes the processing of that data. And you think about, if you have 15 sensors, 20 sensors, something like that on a fully autonomous car today, that's a lot of data that has to be processed. And we're talking about, a small little data center almost needs to be sitting in the center of the vehicle to handle that. Well, that takes a lot of energy, and you have to have very sophisticated high bandwidth networks to move all that data around and then process it in real time. It's not like you can, put it in a queue and then,
Right.
process it 10
Right.
minutes later. It's
Mhm.
got to be instant, because, the second somebody hits the brakes in front of you, the car has to react
You can't
in.
get the like spinning loading shape going
Yeah,
on.
well, by the time you do, you're going to have hit somebody.
Right.
So we don't want that. Um, So that performance of those central computers are driving a lot of architectural changes at the OEMs right now because of that quick reaction time. Then the final thing is, you have all these actuators in the car. You have your braking, your steering systems, your throttle, right? Whether it's an electric vehicle or a gas engine, you still have to tell it what to do, and you have to reliably have those systems react. You're not reliant on the driver to be paying attention and engaged and hit the brake pedal or steer to avoid an object. The computer has to make those decisions and then convert that. So what we see is, especially as I talked about functional safety earlier, in order to have those systems be reliable and perform as intended, you want redundancy in a lot of those systems. So if one part fails, you have a backup system, similar to what's in an airplane that we all fly in today.
Sure.
There's redundant systems, and the reality is, if all of a sudden cars start veering off into the wrong lane when they're not supposed to, customers aren't going to want to ride in an autonomous vehicle, right? Customers are not, or they go and hit a wall. Guess what? We could have very, very negative consequences for that, not just from a business point of view, but from a, potentially loss of life. And that's what we do not want to happen. And that's where ultimately we're trying to help support the OEMs and tier ones to build these systems in a safe, reliable manner.
Right. So, okay, so you guys are doing a lot to support the safety piece and to facilitate some of the AR and autonomous tech that we're seeing more and more and are going to be seeing more and more in the future. So the other advancements, so I want to kind of talk about in the connected car space are around uh, entertainment and
Hmm.
other things that you can do with your screen now that you have a pretty powerful tablet essentially in a modern car. And then
Right.
also because we keep talking about energy, I feel like we should talk about the electric vehicle piece,
Hmm.
managing the batteries and charging. So first, let's
Yes.
talk about entertainment. Tell me about how Infineon is going to help me entertain my children in the car.
Well, they're going to have their phones and iPads in the back for the most part. I know at least mine do, right? They don't look up while I'm driving them around. But no, I mean, when you're charging your electric vehicle, you want to be able to put Netflix or Disney Plus in on your center screen there to entertain if you got to wait for 20 or 25 minutes. So I think one of the things we really work on is you're integrating a lot of different software together to make those systems work, right? You have base hardware platforms, but really what differentiates the entertainment piece is the software in a lot of ways. And what happens is when the OEMs or automaker tier ones design those systems, you need them. It brings in a lot of potential issues because it's like your phone or your laptop. Sometimes when you install software that's written by different third parties, it doesn't always work right. And what we're trying to do is basically help provide ways for the automakers to watch and monitor that software with our hardware and check to make sure everything's performing as intended. One thing is to have abilities to project in different modalities, right? Can you actually project directly on the screen? Can you project or your windshield, or are you projecting on an actual display? And we have different technologies that we're working on that help project those as well. Because ultimately, you're gonna hopefully one day we can just all become passengers, right? And we don't have to drive, and that's still a little bit of ways away. But even with that, as we come more and more of these autonomous systems, we want to be able to relax more in the car and maybe get work done on our commute, as
Right.
opposed to actually, having the stress of driving on a road trip.
Bill, I'm trying to watch cartoons with my kids instead of driving.
Yeah, well, eventually we'll get there. So.
Okay, we'll get there. Okay, so another thing I know, we talked about this on a previous podcast, but just in case other people didn't listen to the previous one, I wanted to go ahead and make sure that we hit on the safety piece, because in addition to trust and stability in functionality around steering and braking and the
Mhm.
autonomous piece and stability in terms of your working with the display, you guys are also kind of helping with the actual battery safety as well. So you want to hit
Right.
on that for us here?
Yeah, I mean, one of the biggest growing areas for us, I mean, you think about the conversion from a gas engine today, which is a lot of steel and rubber and fuel, a lot of hydraulic systems. That's all converting to electric as well, right? It simplifies the overall system, right? But it all comes to electronics. You've got a battery, which we don't do any of the battery ourselves, but we help with the battery management systems. So, what those do is they monitor the health and state of the battery. We offer sensors as well as processors, which help with that. Um, Activity, because you definitely don't want to have a thermal runaway situation like we've seen in the news with certain vehicles. You also want to ensure that your battery health is good. Right, there's a lot of range anxiety that comes up with people transitioning to electric vehicles, and you want
Right.
the battery to be in a very good state of health, so that you don't get stranded somewhere as the charging infrastructure is being continued to build up. It's shown a lot of improvement. It still is being built up, and will continue to improve. You also have the overall inverter as well. So the inverter is essentially what takes the battery energy and converts it into motion in your vehicle, in your wheels. And there's a lot of really high power, high energy semiconductors. You hear about silicon carbide or IGBTs or gallium nitride. That's where these technologies are used, which need to be very efficient. Because if you have switching loss every time you switch at a very high rate, ultimately you're going to have lower range of the vehicle. And this is an area where we're providing technology which can help our customers enable more efficient inverters, both with the processing side. We have some neural network processors which help optimize the motor control of the inverter, your electric motor. We have gate drivers, which ultimately are the ones helping switch all those switches on and off. And then you have the power electronics at the same time, as well as sensors, which measure the current on all these different wires to make sure you're in a safe state of health. You also have the whole charging system, right? So it's not just sticking a gas pump into the side anymore,
Right.
but you have a charger on board your vehicle, which has to convert whether it's high voltage DC or the AC coming out of your wall at home to actually charge the battery safely as well. And all of these power conversion systems, that safety all becomes very critical as well. You want them to act reliably because again, if I'm a consumer and my vehicle, it was very convenient to go to a gas station, and
Right.
now it's not reliable to have an electric vehicle. The consumers will reject them, and we want to make sure that's not what ultimately ends up happening.
Right. I mean, research shows that when people are going to make a big jump in terms of a technological um, aspect of their daily behavior, they want it to
Mm-hmm.
be as easy. There's never a trade-off. We see this all the time in energy research. People are never like, okay, I'm willing to have this be less convenient in order to save money. They're like, no, I want it to
Exactly.
be as convenient and save money. Like that's always the answer. Otherwise, I'll just keep losing money and being convenient. Like that's fine with me. Like I enjoy that because that feels like a very like American way to do it. Just kind of stand there with your arms crossed and be like, no, I want money and the same everything else.
Well,
So
that's all
okay,
new technology, though, right? If it's going to be
right,
adopted, it has to be that easy, and so.
right, okay. Um, so we've talked about. So actually, you touched on something there too that I wanted to kind of visit, just because I think a lot of people don't understand that a lot of the charging activity and the sort of quality of the charging experience is dictated by tech that's on in the car, right? So we call EV chargers the thing that has a plug that's on a pole, and
Right.
secretly that's not really a charger. It's more like a dongle that's bringing energy into the charging apparatus. So I just wanted to kind of call that out a little bit because you guys are working in the important side of it. Let's say no shade on my EVSE
Well,
friends.
I think there's two ways you can charge the car, right? One is you have an external charger, which is when you think about the higher power chargers, the Tesla superchargers, the Electrify America, the EVgo that are doing a couple hundred kilowatts at a time.
Oh, there we
Uh,
go. Bill's saying nice stuff to all of our partners now too. That's
Yeah.
great.
No, I don't know who your partners are, but I'm just, there's a
I
lot of
appreciate it.
those types of companies.
Yeah.
And, those systems a lot of times bypass the onboard charger because it's so much current and they're doing the monitoring, or the onboard charger will monitor it, but not necessarily um, control the voltage and do as much. A lot of times though at home, most of us are not going to have a 100 or 250 kilowatt charger in our house. It doesn't make
Right.
sense. Your house doesn't have the ability to support that. So that's where you have these other systems which are a lower power, but you're plugging in overnight. So you can basically wake up every morning and have a fully charged vehicle ready to go. And so there's really kind of two separate use cases for charging. One is the home, if you're at a hotel, the overnight type status, or at your office. And then there's these faster chargers as well, which are more the roadway gas station replacement type
Right.
systems. And both of those networks are growing tremendously right now.
All right. And you guys are helping push it along with your technology. So that's great for all of us who are EV fans. So before we go here, I wanted to make sure I give you a chance to talk about other things that are going to be happening in the future. We talked about autonomous driving, which is going to be growing and growing. So you guys are going to be growing along with it, and helping push innovation there. And the same with EV in general in terms of working with the batteries and charging. That space is obviously going to be growing. But go ahead and tell us what else Infineon is doing in terms of other things kind of outside the sectors we have talked about
Yeah.
as we wrap up here.
So our focus as a company is to enable two things: decarbonization and digitalization, and those are not unique to automotive. Those are apply to every sector of our lives right now. We have a green industrial power division, which focuses on a lot of the green energy generation, the solar, wind, those types of activities, and enabling those companies, as well as different transportation modalities in there as well. A lot of the conversion of agricultural and commercial vehicles is a big focus. If you think about even the smart homes as well, we have another division which provides a lot of devices to making your home smarter and more efficient, as well as our connected services solutions group, which really focuses on security and wireless connection. Everything's connected, and ultimately, we need to help build that infrastructure to help securely connect all the devices in our lives. So.
That's great. Well, that's all exciting stuff. I wanted to make sure you got a chance to mention the super high tech tractors because, again, the 4-year-old in my life is always in my ear saying, Daddy, what do you know that's cool about your work? What did you do today that's cool? And I want to be like, I talked to a guy about fancy tractors because he'll think that's cool. So, all right. So you help me be a little cooler in my family, which is important because usually mom is the coolest. So I'm just trying to do the best I can. But otherwise, I want to thank you for sharing. Is there anything else we missed that we should be covering? And also, is there anything that you would like to plug anywhere that people can contact you and the information on what Infineon is doing in the auto space?
No, thanks. I think we covered most of it. I think if you want to visit our website at Infineon.com, we've got a lot more details on all the solutions we're developing to support these activities. And would love to, if you guys have questions, you can reach us through that site.
Okay, great. Well, thank you for being here. I appreciate talking to you. I feel like I learned a lot about what you guys are doing, and I always look forward to these conversations. You guys, the folks who are doing this stuff, step away from where my research usually right on the consumer side. So it's cool to talk to people who are working kind of in the value chain and providing the solutions that I'm usually studying. So this is great extra insight for me. It was a great conversation. So I appreciate you, and I hope people will reach out with any additional questions they have. Now, connected consumers, if you want to contact me or anyone at Parks Associates to learn more about any of these topics, please let me know. I'm on Twitter at CWhiteInsights or Chris White on LinkedIn. Also, Parks Associates LinkedIn is a great place for free research, data points, industry news. Elizabeth Parks, my boss, has a huge following and does a great job of putting together content that she shares. So everyone should be following her on LinkedIn. And also follow Parks Associates on Twitter as well at Parks Associates. Also, be sure you like and subscribe in whatever modality you're kind of consuming this content right now. We really appreciate it as we continue to grow this platform and be more engaged with you guys. Please leave comments and let us know who else you would like to have on the pod, who you would like to hear from, questions you would like covered. If you want to come on, also, please hit us up for that. And we will catch you guys next time. Thank you, everyone. Connecting Consumers. Bye-bye.